Okay, so a few months back I made a game called WebGuy VR, which got way more traction than I expected, and it's basically just a Spider-Man VR game. I today am going to show you how to make your own Spider-Man web swinging for Unity in VR. Okay, just blank Unity 3D project. I'm going to go through the VR setup first. You can skip through this if you already have VR setup or anything like that. So we're going to go Window Package Manager, change it to Unity Registry and find the XR plugin management, install that. And we're also going to install the interaction toolkit. We're going to click yes. I made a backup go ahead and it should restart the Unity editor. Okay, now we're back, just going to check the input system has been installed, which it has. Going to head down to the XR interaction toolkit and install the starter assets. And we should be done with the package manager now. Head to edit, project settings, XR plugin management. We're going to turn on OpenXR because then we can just use any. Click on this little yellow icon, click edit. That'll take you to this section. Add any of the interaction profiles you want. HTC Vive, I'm going to add Oculus Touch, Valve Index, Microsoft motion controllers, that'll do. If you're also working with Oculus Quest, you just have to turn it on here. And fix your color space. We can close that now, head down to this section again, and add the Oculus Touch controller profile. And Oculus Quest support. Okay, next, you're going to want to head down to Samples, XR Interaction 2.2, Starter Assets, and go through each of these and just click Add to Action Base, like that. Click Get Project Settings, Preset Manager, and right for the XR default right controller and left for the XR default left controller. You can close that now. Come in here, add an XR origin. My bad, I meant XR origin action based, and that'll add the XR interaction manager where you can input action manager, add XR default input actions. If we now click on the XR origin, set the tracking origin mode to floor and add a plane, reset the transform, and click play, we should be taken into the game. Before we move on to any of the fun stuff, I'm going to quickly make a material for the floor, drag it onto the floor, change the color so it's not so bright, and if you just click this little section up here, you should have this default checker. I'm just going to change the tiling a bit. I just think it looks nicer than the flat color. Okay. Next up, click on the XR origin, add a rigid body, and constrain all of the rotations. Now, you need a rigid body for this to work because the web swinging uses physics to control everything. So if you're using a character controller, you'll need to either switch that out for a rigid body or enable a rigid body and disable the character controller when web swinging, which I'm not going to go over. We're going to right click on the origin, add an XR Locomotion System action based. Going to delete the teleportation provider and add a continuous move provider action based. Now I'm just going to mess with the settings on here, so we're going to change gravity application mode to immediately, change the forward source to the main camera, disable the right hand move action, disable the left hand snap turn action, change the debounce time to 0.2, and disable turnaround. That's just what I like. It's up to you whether you do that or not. You can add the XR origin in there if you want. It doesn't change anything, but add the locomotion system into the continuous move provider. And now if you click play, you should be able to move around and turn. I forgot to give the player a collider, so add a capsule collider. set the radius to, I like 0.15, the center to 0.5, no, the height to 2, center to 1. I think that's right. Let's quick play really quick. And if you look in the XR origin, we now have movement, snap turning, all of that. One thing is that you can see that my head is here, but the capture is still this big, so I'm going to quickly write a script to change the capture collider's height based on the camera position. Now, you may know that there is a character controller driver already, which is basically what I'm going to use, but I'm going to turn that into a capture controller driver instead. So I'm going to create a new script. And create an add. Now if we open up the character controller driver, there is one function, here it is, the update character controller. Now this uses the XR origin and the camera to get a height, and we're basically just going to take this code. To be fair, we don't need this bit at the top, so we'll just take from our height, all of that. And we're going to use that in the capture controller driver. So in update, just going to paste that in there, and we're going to get a bunch of errors. So we're going to make a public XR origin, and you can press Alt and Enter in Visual Studio to get this using tag, or you can just type it up top. And we're going to name that m_XR origin. We'll see that error go away. We need two public floats for m_min height, and we'll also need one for the max height. We'll also need capsule collider. We'll call this collider. And we'll change this to collider.radius, I think? Yeah. And we'll change this to collider. And we'll change this to collider. I'm just going to put an m_ like everything else to get rid of that little error. Or, to quickly change this, you can press Control and R twice, and you can rename this, so m_collider. There we go. That should all work. So remove the remove the character controller driver, add the XR origin, just set the max height as high as you want, and the collider is that. So now if we click play, you can see that the height of the controller is changing based on where my head is. So if I crouched, it would count that as crouching, you get under small objects and stuff like that. Okay, now on to the fun stuff. On the left-hand and right-hand controllers really quickly, we are just going to delete the interactor visuals, the line renderer, and the interactor. I'm going to add a direct interactor and sphere collider, set the sphere collider to is trigger, and set the size to about 0.15. We're also going to add spheres underneath both of these objects, and set the size to 0.15. And remove the sphere colliders. There you go, the hands are now spheres that can pick up objects, but that's not anything I really care about right now. What we care about is adding a web shooter component. This is going to be a custom script that we are going to write right now. Okay, we're going to start off by making some variables. So we're going to need a public transform called shooter tip, a public rigid body variable for the player. We're also going to want a game object called web end, This is something we'll add in a bit. Now for private variables, we want a private spring joint. I also forgot a few other things up here. We'll need a public line renderer. We're going to also want some... I'm going to quickly add a header up here. You can use these square brackets to add headers in the inspector, if you didn't know. So these are all variables. We come down here. We'll need some web settings. So we'll need a float for the web strength. And we're going to set some defaults for these. So 8.5 is what I use. Web damper is 7. Web mass scale is 4.5. And web zip strength is 5. But the web zip strength is something I'll probably add in another video. A few more things we're going to need. We're going to also move this private spring joint down here. We're going to need a fixed joint called end joint. That's for if the other object has like a rigid body or something. We're going to need a private vector3 web point. This is where we'll store the place the player is shooting. And we're also going to store the distance from point. We're going to open up an awake function, and in here we're going to set the line renderer to be equal to get component line renderer. That's it for that. In update, we're going to handle input. Okay, I've just been learning about this because I didn't know how to do it before, because I usually use a different system for handling input and stuff, but to get the trigger, which is what I use in my game for handling whether or not you're shooting the web, we're going to do a public action-based controller. And we're also going to need this using reference up top. We call this controller. And in handle input, we're going to do controller dot, I think select action, dot action, and we're going to do a read value. This is a bool. We're going to need to create a bool that is pressed. And we're just going to print that for now and make sure that it's working. So if we just come out of here, I can also show you how to assign all of the different variables that we have. So we're going to need to add a line renderer, like that. I usually set the width to about 0.02, you can still see it. We're going to turn the positions to 0 for now though. We're going to assign that there. Web end, we'll do that in a minute. We're going to add the rigid body to that. The shooter tip, just going to create an empty game object and add that in here. I'm going to close the XR controller action base and all of this. There we go, shooter tip, just add that there. And the controller is the XR controller, just like that. You'll need to do this for the left hand as well, but I will go over that again when we've written out the entire code. So I'm going to put my headset on and open up the console. Okay, turns out I've done that wrong. It's not the select action. My guess is it's the activate action. And it's also a float, apparently. Which makes sense, but... Also, we need to change this to be a float. Okay, now if we head in and just press the trigger... Nope, I was wrong again. Oh, no I'm not, I'm right. So if you hold down the trigger, you'll be getting 1, and if you're not, you'll be getting 0. So 1 means you're holding the trigger, 0 means you are not. Pretty simple. Now we're going to open up an if statement. I'm going to say if is pressed, and if we are pressing, we are going to... Oh, and if isPressed is more than 0, and we're going to need to make another private variable, private bool web shot, I'll do, and not web shot. Then we will set web shot equal to true, and we will call a shoot web function. We'll generate that method. We're also going to have an else if, for if isPressed is less than equal to 0, which is only going to make it equal 0, so let's just do equal 0. And web shot, then stop web. That's going to be another method. We're just going to move shoot web to be above stop web. I just prefer how that is. You don't have to. It doesn't change anything. I just prefer it. Okay. Now, here comes the fun stuff. We're going to create a raycast hit variable called hit. I'm going to say if physics.raycast, and we're going to be raycasting from the shooter tip.position using the shooter tip.forward. I'm going to pass out the hit variable. We'll have a max distance, and we will need some layers. Also, this max distance just doesn't exist, does it? No. So we need a public float for max distance, and a layer mask for the web layers. Web layers is just all of the layers that you'll be able to actually web onto, I guess. We are going to set web point to equal hit.point. We're going to set joint to equal the player.gameObject.addComponent, and we're going to add a spring joint. Joint.autoConfigure connected anchor is set to false. Joint.connected anchor is equal to web point. Basically speaking, that would work. We're also going to set the distance from point equal to vector3.distance player.transform.position web point, and we're going to multiply that by 0.75. That's going to get us 0.75 of the distance, or 75% of the distance, which just gives the web a bit more spring compared to if we didn't have that. We're also going to set the joint.min distance to equal 0. Joint.distance from, or .max distance, sorry, to equal distance from point. Joint.spring will equal the web strength. We're also going to need to set the joint.damper to the web damper, and joint.mass scale to web scale. Now, that should work. We just need to make sure we can actually stop the web as well. So we are going to destroy joint, and if end joint destroy end joint. Now that's just going to return false all the time now, because we're going to add some code in here in a second, but for now that should work. So we just head inside. We're going to add a 3D object cube. I'm just going to put that up in the sky somewhere, and we should probably add the line renderer code. I forgot to do that. Okay, okay. So we are going to need to quickly, underneath web point is equal to hit.point, we're going to add web end is equal to, or web end.transform.position is equal to web point. And in update, we're going to check if web shot, we're going to set line renderer dot position count to 2, line renderer dot set position, we're going to set position 0 to web or shooter tip dot position, And we're also going to set position 1 to be web point. No, wait, web end, I think. Web end.transform.position. There you go. Now down in stop web, I forgot to set a bunch of stuff up, so we're going to set line renderer dot position count to 0, and we're also going to set web shot to false. Although we should probably handle that up in here under the handle input next to stop web. Now we should be able to see our webs being shot. Let's head over to the right hand controller, make sure nothing's missing. Alright, max distance. This is how far you're going to be able to shoot your webs. So I'm going to set mine to 1000. And we're going to set the web layers to default. You can set that to whatever you want though. Same with all these strengths and stuff. That can be up to you. Okay, let's head into the... Okay, I've realized the first error already. We're going to need to make the web end. So in the right hand controller, we're just going to make a new empty, call it web end. We're going to drag the web end game object into there and head back out into VR. There you go, you can see that we're getting something. It's not quite what you probably expected because it's barely working. But I mean, it feels kind of like swinging. One thing which I forgot to set is in awake, we need to set web end transform.parent to null. That would basically just mean it has no parent. But we still have a reference to it. And down here in update, we're going to check for if we also have a joint, just in case we don't. If we head out now, I'm going to quickly open up the line renderer and just give it a material. I don't really care what material. Let's go with this default line material. That'll do. Okay. As you can see, now the web is staying in place. If we drop down, we are swinging. There's a few little errors we still need to iron out, but the core of it is working. You know, you shoot your web, you drop off the edge, and you swing. That's a decent start. We are now going to handle physics, so we're going to add a cube and give it a rigid body. I'm going to show you what happens right now. If you shoot it, okay, that's fine, but if we hit it, apparently our mass is too short, but you can see that the web isn't moving with the object, which is not very helpful. So we are going to open up our script, and this all happens down in the shoot web function. So after we set up the joint, we're going to do if hit.transform.gameObject.tryGetComponent. We're going to try and get a rigid body, and we're going to pass out a rigid body, call it rigid body with no capitals. And we're also going to do if rigid body just to make sure. I'm not sure if that's needed or not, but I'm going to double check anyway. And we're going to change some of the joint settings. So we're going to change joint.connectedAnchor to be a new vector3 at 0, 0, 0. We're going to set the the web end to be. Oh, we're going to get the component rigid body. I'm going to set is kinematic to false. We're going to set end joint dot. We're going to set the end joint equal to web end dot add component, and we're going to add a fixed joint component, and we're going to set the connected body of that end joint to be equal to rigid body. We're also going to set joint.connectedBody equal to webEnd.getComponent rigid body. This will basically make sure physics interacts between all of these. And we're also going to do a quick if not rigid body webEnd.getComponent rigid body is kinematic equals true. Now if we head down to our web end and give it a rigid body, we're just going to set it to is kinematic, turn off use gravity, and that should work. Now I'm going to quickly turn up the mass of our, actually we just turn down the mass of the cube. We'll just turn it to 0.01 or something. I also want to turn off the speed of the continuous move provider. But again, that's all up to you. We click play now. We can shoot this and we can pull it around and the web will stick with it basically. Now I guess the last thing you need to do is set up the webs on the other hand. So we're going to add a web shooter component and a line renderer component. Again, set the width to 0.02, positions to 0, give it a material. Close that up now, drag it into there, drag the XR action controller in there. We're going to add two empties, one called shooter tip, one called web end, give web end a rigid body, set it to is kinematic, turn off use gravity. We'll drag web end into there, shooter tip into there, drag the player into there, set the max distance, and set the layer to default, and boom. You can now shoot webs in Unity. That's pretty much it. I hope this wasn't too long. I know it's quite long, but I hope you enjoyed, I hope I helped, and I will see you next time. Goodbye.